Hi, a friend of mine asked would I be to have a look at this Milwaukee Drill that stopped working. So I've just plugged a battery onto it. I don't know if you can hear that little click. Every time you pull the trigger, the light comes on and you just get a little click, and that's about it. So I'm suspecting probably blown MOSFETs on it. So to get it apart, it looks like we may have to remove these 4 screws here to get the chuck off, and then remove these screws around the outside to get the casing off. So let's do that. And I think it's a Torx T10 bit. So I'm going to start by removing the chuck. Now, we're not taking one of these apart before, so I might just have to remove the screws out of there and then undo this side casing. So let's try that next. Right, let's see if the side cover wants to come off. So this is the brushless motor, and this is the control board for that here. It's got the on-off switch, which has got a resistor in to control the speed. And this is just the connector block for the battery. So a common problem on Milwaukee power tools, and probably other power tools as well, is the MOSFETs that control the motor blow. And sometimes what happens, unfortunately, is if it's the positive MOSFET that blows, it can then send the 18 volts from the battery back into the little microcontroller, which you might just be to see down here. So this may or may not be repairable depending on what we find. So let's see if we can get this apart a bit more. Let's see if we can get the electronics out. A forward and reverse switch. And get the casing out of the way. Let's just see if we can see any obvious signs of damage. Well, I can't see anything obvious. Let's just zoom down a little bit more. So I think I might have to remove this heatsink next, which is held on by these 4 screws here. I'm just wondering if we can actually test anything. We do have some test pins here. Now they may go to the gates of the MOSFETs, which may give us some readings. I might try that with the meter first, but obviously with it connecting to the motor and that stuff, we could be measuring a lot of stuff in circuit as well, so it may or may not work. I'll just go and grab the test meter a second and see if I can pop that a little bit with the battery, just to hold it in place. Right, I've got the test meter here. What I'm going to do, I'm going to go from the other side of the power switch, which is this blue wire here. I'm just going to go on to these points here, just to see if we get any continuity, because I think these will go to the gates of these MOSFETs. So if one of the MOSFETs are shorted, we might get continuity from this point to the gate. So let's go on this one. Nothing there. Try that one. Yeah. Let's try this bottom one. So to me, it looks like we've got a short on this centre MOSFET here. Let's just try on the negative. So I've got a reading there, a reading there. Not sure if I'm on that point properly. No reading there. Could be this conformal coating as well. But it definitely looks like there's a MOSFET blown, and it looks like the middle one here. Now unfortunately it looks like it's the positive one. So because we've got positive, hold on, there, because the positive comes from the battery, goes to this point here, and it's being fed. It's fed back into this IC here. So what I might do is remove the MOSFET, and we'll see if this chip starts getting hot with the thermal camera. I mean, we could probably just see if that gets hot with the thermal camera in any case. And if it does, it's probably not repairable. So let's just try that. So go and get the thermal camera, and we'll just monitor this IC here. Right, I've got the thermal camera set up. It looks like that chip's already warm and it's not even powered up. I mean, you're not seeing any real hot spots, so it may well be okay. Right, let's take the battery back off. Let's see if we can get this heatsink off. Let's see if I can get a different screwdriver just to try and prise that off a bit. Yeah, well, it looks like I was right with the test meter then. I'd say that MOSFET there has definitely failed by the look of things. You see a bit of a black mark around here, and I don't know what's happened there. It looks like it's got a big crater in the top of it. So that's the problem. So we've got a current sense resistor here. So obviously it'll be detecting that the current is exceeding what it should be, and it'll be shutting it down. Now I might have actually some of these MOSFETs, because I bought some for, I think it was a Milwaukee Sawzall. But unfortunately it had fed back to the main microcontroller, so it wasn't actually repairable. Somebody else actually sent us a replacement board for that, which came all the way from Australia. So I still might have another go at that one. Well, we'll have a look. We'll have a go with this. We'll see if we can change that MOSFET, and then we'll see if this is actually going to work or not. It still mightn't yet, but we'll give it a go. Right, I've got it under the microscope. I'm just going to add a little bit of flux to this first. Right, let's get some hot air on it. Right, I might add some fresh leaded solder to that, just so it's a little bit easier to melt. Just going to add a little bit of flux first, I think. I'm just going to clean some of that back off. I think that'll probably do. I think what I'm going to do is just add a little bit of flux to this and just heat it up with the hot air, just to flatten all of these off first. And then we'll put the new part in place. This has actually got solder on the bottom already, so let's try and get that lined up. I think that's about it. Right, I've just gotten the microscope out of the way. So let's measure from this blue wire now to those 3 points. And we don't have any shorts now. We're just going to diode check again. And I go on to the output of the motor, which is here. You can see we've got no shorts going to the motor. And if I go into the negative wire, we shouldn't get any continuity to the motor either. We're just getting a diode reading through the MOSFETs that are switching the negative to the motor. But we don't have any shorts. So, has it damaged the microcontroller? That's the thing. So I'll get the heatsink put back on and then we'll give it a test and we'll see what it does. Right, that's the heatsink back on. Right, I think I'm just going to put a few screws in this just to keep it together, just while we give it a test. Actually, that might be jammed, because it's not turning. I might have jammed it up now, putting it back together. Because it just didn't have the motor quite in line, so let's just continue putting this back together. I think if you haven't got all of the screws in as well, it doesn't hold the motor quite straight. Let's see if it works. Excellent. I think it's one of the phases on the motor isn't quite working properly. It could well be that it's blown that microcontroller. Like I say, it was the positive one, so that MOSFET I've put in might be being switched. Because if I move the motor one phase there, so it's not working on that phase, which is the one that it should start with. But if I move it down one phase, or two, it fires off. So it could well be the microcontroller's gone on this. Right, so I've just got it under the microscope here, and I'm just going to check the gates on those MOSFETs. So that one's okay. Let's check the one that I've just done. And let's just check the end one. So all of those MOSFETs seem to measure correctly. We have a 10 ohm resistor here. Let's just check that. Let's just check the resistor next to it. I think we're just measuring other components. Well, we're getting the same readings on all of them. So if that MOSFET wasn't connected correctly, we'd be getting a different reading on that one. We do have a few diodes here. I can just double check those as well. So all of that part of the circuit checks out okay. Like I said, because this is the voltage side, which has got 18 volts on it, normally when these blow, it sends 18 volts down through this pin here, which, if you remember, was shorted to the supply, and it back feeds into the microcontroller here. So unfortunately, I don't think this is going to be repairable, this one. It's a bit of a shame. That's just the way it goes sometimes. So I've tried tracing back from the MOSFETs, and each one of the gates goes to a 510 ohm resistor that then goes into the microcontroller. I've checked those resistors, they're fine. And just for belt and braces as well, I tried reflowing the MOSFETs that I fitted just in case it wasn't making a contact properly, but it's exactly the same. If you go backwards, it'll work again. So it's not given the signal to fire that MOSFET because it must have damaged the I/O pin on the microcontroller, unfortunately. And you can't change the microcontroller because we haven't got the software to put in it, because the software doesn't just control the motor, it also monitors the battery voltage, makes the light work, adjusts the speed, it does a few different things. So unfortunately, no fix on this one. So not to end on a low note, why don't we have a revisit on the Milwaukee Hackzall that ended up being the same, but somebody's very kindly sent me a replacement board for it. So let's see if we can get that one up and running. So this Sawzall I looked at in a previous video, and the problem with this was there was two of the MOSFETs that were blown in it, but it was all encased in resin. Like this. Now this is a replacement unit that somebody else has sent me from Australia. So I can't remember exactly who sent us it now, but thank you very much for that. So unfortunately, after I replaced the MOSFETs on this, it still wouldn't work. It was just pretty much dead. I think the light lit up and that was pretty much it. We'll actually try it again now. I'll just try plugging some power into it. And we get the light. And that's about it. So this one doesn't actually do anything. There's just no motor output at all. Like I said, a common failure on these is the MCU when voltage gets fed back into it. So I'm going to swap the motor and the trigger assembly over with this one, and then we'll see if we can get this one up and running. Right, that's the old one off. And you've got to make sure that this notch is facing up over, otherwise it doesn't go back together properly. Right, I've got to remember how the rest of it goes back together now. Let's see if we can get this back together. Right, let's see if this works then. And it seems to. Excellent. Well, at least we'll fix something. So, right, we'll call this one a fix then. Right then, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.